Okay, so I hope the screen is visible to everyone.
Yes, sir.
Yes, sir.
Okay, and one thing more, I have just created a Google Classroom page and I have invited you all to join it. So kindly join the page, and I will be putting up the study material on that this classroom itself. Okay, as well as whatever assignments in soft copies you would be submitting, you can submit it on the Google Classroom page. It is very easy to use. You just have to open it and join it, and there you will get the space or the place where you need to upload the given assignments. Okay, that will be visible in the given section. I don't know what is visible to you. I think it will be in the classroom materials or assignment section. Okay.
Okay, sir.
So for timing, like we have planned the first assignment or the task for you, which would be a small presentation of 4 to 5 slides covering the various levels of automation applicable to a particular process or an object or a machine tool. Okay, so you just need to identify that and try to correlate it with the various levels of automation, and that presentation you will be submitting it on the classroom also, and you will be presenting it in the class also. So yesterday I've told you that it will be on the next Friday, but on Friday you don't have lecture, so we will be doing that task on Thursday, that is 20th of January. Okay, just try working on it,
Okay,
and
sir.
if you face any difficulty, you can ask, not a problem. Okay. Okay. So continuing with the chapter 1, that is the introduction to industrial automation. So we have just tried to understood the various levels of automation yesterday, and why the spatial to time ratio is increasing as we are going upwards. So spatial word here means that how much of the a particular level is involved with the given process. Okay, so sensors are involved at a very lesser level. That means they are just present for each and every process individually. Whereas as we move upwards, the amount of involvement of each and every level keeps on increasing. That is why its spatial data is increasing as we are moving upwards. I hope you are understanding what I'm trying to say. You understood it? Yes, or
Yes,
not?
sir.
Okay. So what I mean to say is that sensors and actuators are actually involved to very small processes, whereas the upper levels are involved to much higher level of processes. So coming to the time scale, that means how much data for a given time period is available to us. So a sensor can collect large amount of data for a given time period, whereas the upper sections, they consider data for larger time durations. As we keep on moving upwards, the time duration for which the data is available to us is large. That means the spacing between time duration is large, but for a given time period, the data is small. Okay, if we take example of sensors, sensors are collecting data for even for a microsecond or a millisecond. So for a given, once if we are collecting a data for 1 minute, so sensor will be giving us lakhs of values, whereas automatic control may be giving you 10 to 12 values. Supervisory control won't be giving you any value because it may be considering the value of 1 hour or 2 hour time period. Production control will be covering data for 1 day, 2 days. Enterprise would be covering it for weeks or months. So it's like that. Okay. So the time period is very small for sensors, but the duration it is increasing as you move upwards. That is what this spatial to time ratio means. Okay, now coming to the next slide, that is types of automation in industry. Okay, so what are the various types of production systems and what are the various types of automation systems applicable to these production systems? Okay, so from industry point of view, as we are studying industrial automation, so we need to consider the aspect of the industry where a manufacturing or a service is going on. Okay, so if we see the in an industry, if there is some production system applicable, so if I ask you what do you understand by a industry, so you will first ask me that which type of industry are you talking of? Are you talking of a manufacturing industry? Are you talking of a service industry? Are you talking of a banking industry, financial industry? Which type of industry am I talking of? So from, because all of you are going to be mechanical engineers, you are related to mechanical systems, manufacturing systems. So here in most of the time we will be talking of manufacturing industries. That means the factories, the production systems where some or the other part is being produced by different processes. Okay. So here also, if I am talking of types of automation in industry, and this automation is applicable to different type of industries, that means it is applicable to different type of manufacturing systems. Okay. Okay. So manufacturing systems. So manufacturing, or you can also call it a production system. Sorry. Or also called a production system. So there are basically three types of production systems. Kindly be attentive. So a mass production system, a batch production system, and a job type of production system. So what does these three, this is the broader category which we are talking of. So when we are producing a particular part in the factory or the industry, so we are either producing it in mass, that means the industry is only producing a single type of object throughout its time duration, whole time duration, or whole manufacturing time. Okay. So you can take an example, like if a particular type of industry is there and it is producing some nuts and bolts of, it may be of different kinds, but the overall product is the same. It is a nut and a bolt. So it is producing the same product throughout the year. So that is the type of a mass production system. Okay. So mass production system is the one which is producing a single type of product throughout its whole duration of manufacturing time. Batch production is the other one which produces the products in batches. So batches can be of different time durations. So like for 3 months, you could be producing one product. For the other 3 months, you could be producing other product, and so on. So you keep on changing your product after every 3 to 4 months. That is a type of a batch production system. Thirdly, we have the job type of production system. So job type of production system is generally focused on producing a single type of product during its given time duration. Okay. So it will be producing only a single product. So what could be the example of job type of production system? Shipyard industry, which is producing a ship. So that ship is basically produced as a single unit only. It may be taking 6 months, a year also. Similarly, if we consider the aircraft industry, there also a single type of aircraft is being produced for a given time period. Okay. Third example could be, suppose you are making prototypes of different designs. Okay. You want to produce something new. So you are just playing with different technologies and trying to produce new type of prototypes, which hasn't been finalized yet and its production hasn't been started. So before that, you are going with trials. So you would be uh, giving trial to different type of products by making small changes here and there. You will be testing it. So that is prototyping. So that is another type of example of a job type of production system where a single part is produced. Okay. So in most of the industries, we are having a batch type of production system where a given product is made for some time. You can see the automotive industries also, they are planned that for on this assembly line or production line, a particular type of vehicle will be produced for this much time period. After that, you will change it and a new product will come that will be produced for this time period. So companies have planned their systems like this, that for as per the demand in the market, this vehicle has more demand, so we will keep the production line for this vehicle for a more larger time period, and after that we will make certain changes in the system, and what we will do, we will make it applicable to the other type of product which needs to be produced. Okay, so you see that now I have told you that if you are planning for small batches which require change in product after a small given time period or a larger time period also, what we are doing is we need to change the system. The production system needs to be changed accordingly. That means the tools, the machines, the movement of the material, quality check of the material, everything will be changed according to the new product which is produced. That means as the number of products they keep on changing or increasing or decreasing, there is a requirement of change in the production system. Okay, so you can't have a fixed type of system. You need a flexible type of system. Okay, so what we want to say is that for a mass type of production system where same part is produced, a fixed automation or permanent type of automation could be used. Whereas the system which is having a batch production or a job type of production, there the product which is produced is changing with time, so we require flexibility in automation also. So we require programmable or flexible automation. That means flexible system is which changes with changes easily with time. So it is flexible. We always say that he is a flexible person. He can or he is capable to change with the given requirements or given demand. It can change his or her actions, and so it is he is a or she is a flexible person. Okay, so flexibility is the ease of changing with time or with given requirement. Okay, so I think you have understood that if there is industry producing same type of product, it will be requiring a permanent or fixed automation. Whereas an industry which is producing the products in batches or a job type of production system, that is a single product, there you will be requiring very fast change in automations or system, because you want to introduce or fit the new system in the same place. Okay, so if we take some examples of a fixed automation, what could be the examples of a fixed automation? Fixed automation means that in a given industry, you have fixed places of machines, you have fixed places of material movement, and you have fixed places of the person which would be visiting the places and which would be overall supervising the process. So everything remains fixed. So for a fixed system, what is there? The machine tools which are placed, they will be fixed. The material movement will also be fixed. So that is why a conveyor belt type of material movement system is applicable to a fixed automation. So have you heard of conveyor belt or have you seen a conveyor belt? Any one of you?
Yes, sir. Yes, sir.
Yes, sir.
Okay,
Yes,
very frequently used, okay, to move product in masses from one place to another place. Like if any one of you must have visited the airports, there also the baggages, they are just moving on the conveyors where you can just go and select or pick up your luggage after inspection. Okay, so that is a conveyor belt. So that means if you are installing a conveyor belt for automation, there you are going for a mass production system, because after assembling all those things like conveyor belts with the machines, once you have installed that, it is very difficult to change its position and location. Okay, so that is why it needs to be decided in the first instance itself, that which type of production system would be applicable to the industry or the part of being manufactured in the industry. Accordingly, you will decide for the automation. If we talk of flexible automation won't be having any conveyor belts. There, although the location of the machines will remain same, if we consider the flexible automation, the machines which are located, they will be same at same positions, but you can reroute your material movement as per the requirement of the batch. So suppose first 10 machines are used for batch production of first part. Now for the second part, maybe first, third, fifth, eighth, 10th, 12th, such type of machines could be used for production of the next part. Okay. So there you can, what you can do is you can reroute your movement of the unfinished parts within those machine tools. So for that, we will have not a conveyor belt, but we will have something else like an AGV, automated guided vehicles. We can have robotic arms where the robots can be reprogrammed, and robotic arms, if firstly installed between one and third machine, one and second machine, it can move between first and third machine also. So you can have flexibility with the application of. So suppose these are the machine tools over here, another machine tools over here. Firstly, suppose the part was moving like this from this part to this part. In second, it may be moving like this to this, something like this. Okay. So if a robotic arm is installed over here, firstly, it may be working between these two machines. In second case, it may be working between these two machines like this. So such type of flexibility will be there for a batch type of production system. And a programmable automation is a complete, you can say, automated system having maximum flexibility. So programmable can be considered as a one level up the normal flexible automation system. Here the machine tools also will be movable. They will also not be fixed, because suppose there was an airplane which was being manufactured earlier. Okay. There the machine tools were installed at these levels around the airplane and you were working on it. Now, next time the product has changed, its size has changed, its location has changed. Now machine needs to be moved to new locations and the material movement will also change and the location of the machines will also change. So complete flexibility when the new product will be introduced. So job type of production system, maximum flexibility. So I hope this is understood to you.
Yes, sir.
Every one of you can just answer. There is,
Yes, sir. Understood.
okay. I think Balraj is present. Yes. Who is not present today? Rajan is here. Who is not present?
Sir, Rishabh.
Rishabh is not present. Yes. Okay. So Balraj, you are understanding what is being taught because you were not present in the first lecture. So I think you have covered it because not much of the
No, sir, I'm understanding.
part was covered. Okay. Sanidhya?
Yes, sir, I am able to understand.
Okay. 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 So after types of automation, a simple introduction to the mechatronic system, as we have discussed that you already have studied this subject in the previous semester, but it has applications in this particular subject also. So we need to just have a understanding of the mechatronic system again. So we will just go through it again. So just read the definition. So mechatronics is the synergistic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware and software to manage complexity, uncertainty, and communication in engineered systems. So very long and a little complicated definition covering number of things. Okay. A synergistic integration, systematic integration of the sensors. We know what is a sensor, actuator. First, the sensor senses the thing, then it actuates some mechanism, and that mechanism will produce some signals which needs to be. Signal conditioning means we have to filter out the important signals and just throw away the noise signals which are not useful to us. Okay, power electronics, the electronic parts related to power systems, and then algorithms which are running for decision and control, and computer hardware and software, which is the part of the IT section to solve the engineering problems. So it's like that. Okay. So this is if we try to understand it through this flow chart, we can see that mechanical system or mechanical engineering has given rise to a mechanization. That means the thing which we have studied in the first lecture from the definition of industrial automation, कि सबसे पहले मैकेनाइजेशन आई है ना, कोई सिस्टम को इंटीग्रेट करके आपने अपना काम इजी किया, and you got a mechanized system which comprised of 2 or 3 links which were having a mechanism involved, and your work become easier. That is mechanization. And then we try to introduce the electrical technologies with it, such that the repeated task could be done using those electrical devices, okay, like electric motor. So some repetition work involving rotation. This is an example. If you are rotating a given thing after a certain time period, it could be attached with a camshaft, which is a mechanical system, and camshaft will give a signal after some time, and the motor will rotate. So what you have done is you have given given assistance to the mechanization system where repeated job is going on. Okay, so it would be called an electromechanical system involving electrical as well as mechanical systems. So simple mechanism and electrical system is used to do the repeated job. Now further, if we have added some electronics and information technology to it, it becomes the mechatronic system. So now we want that although a repeated job is done through electrical systems, now some logical sequence could also take place. Okay, logical sequence means some operations which need to be done at a certain time period after one given task. So you wanted to make a sequence of operations that firstly this object will move to from 1 to 2, then the second task, that is rotation of that machine, should start. Okay, if you have added some such type of sequence, okay, machine 1, 2, so you have added that firstly my material should move from 1 to 2, then only this machine should start. This is just an example of sequencing. So you can have sequence in anything. Okay, like if I come close to this door, then only this door should open. If the object is placed in front of this robot, then only it should start picking up the object. Otherwise it should stand still. So anything could happen in a sequence of operations. Okay, so what we wanted to do is, after making the electromechanical systems, we wanted that some sequencing operations could also be followed, where the operation could take place in sequence. But firstly, this should happen, then this should happen, then this should happen, so that our whole process becomes automated. Okay. This is one example. Another example could be like, if I am getting, now I have made my system electromechanical system, but I don't know if there is some error occurring or not. आपने तो अपनी तरफ से कह दिया कि मुझे अब 10 meters distance move करना है, अपने system को बता दिया. For that 10 meter distance, the motor may be moving the wheel of a given vehicle by for like 30 seconds at a 50 RPM speed. Just an example है ना. आपको 10 मीटर डिस्टेंस मूव करना था, उसके लिए आपकी मोटर रन की 50 RPM पे 30 सेकंड के लिए. Now have you actually reached that 10 meter distance or not? That means a feedback system should be there which should work on its own, and if there is any error, that means whatever distance you have decided to reach, has it reached or not, accordingly it should compensate to the error. That means it should give extra movement to the motor accordingly. Okay, so that type of feedback system was also desired, which led to the integration of electromechanical system with the electronic system. Okay, and finally, when all those number of electronic systems or electromechanical systems were integrated with each other so that they could be controlled by a single system through a software, through networking lines, there is the part of information technology which came into existence. So all of them made the mechatronic system. All of them made the mechatronic system. So mechatronic system can also be called the mechanism plus electronics. When integrated, it gives rise to a mechatronic system. So mechatronics is having a subset of mechanical engineering, electrical, control, computer engineering. Okay, so control is nothing but the electronics engineering. Okay, so this is another figure which is showing the mechatronics and its definition. So I hope it is understood.
Yes, sir.
You
Yes,
can
sir.
always ask questions in between. If you have any doubt, you can also always ask. If you're not asking, it means two things are maybe happening. Either I am teaching very well or you are not listening. Okay, so two things could be happening. या तो मैं बहुत ही ज्यादा आपको अच्छे से एक्सप्लेन कर पा रहा हूँ, है ना, सब, पर ये भी चीज पॉसिबल नहीं हो पाती कभी ना कभी, किसी को कोई डाउट आता ही आता है. Otherwise, second thing is that you are not listening carefully. Okay, so please be attentive. Basic elements of a mechatronic system. So just look at this block diagram figure, very important. So any basic mechatronic system will be having a mechanical system in the center. From those mechanical system, digital and analog sensors will be taking some data. They will be sensing some data from that mechanical system when it is working, and they will be giving that data to the microprocessor or a microcontroller, which is controlling the process. And then that microcontroller or processor will give signal to the digital or analog actuators, which will then run the mechanical system. Okay. This could be easily understood by taking this example of a mechanical system where there is a transmission system working. Here, the data, if directly taken in the digital form, can be directly sent to the microprocessor. But if the data is in the analog form, then it first needs to be converted from analog to digital system. Okay. Then that digital value will be processed by microprocessor, which will give the results in digital form, but the actuator will be running in the analog form. So it needs to convert that data into analog form first, then analog actuator will directly move the mechanical system. Okay. So this is one example. Another example could be if we take the example again of CNC machines. Okay, very good example again for CNC machine. A CNC machine tool written like this, MC. Okay, machine tool. So what is the purpose of a CNC machine tool? It is used for cutting of material. Okay, in simple words, fabrication of material, machining, cutting, whatever you can call. So what is happening in a CNC machine, as we have already discussed, that the material and the tool come in contact with each other, and tool having more hardness than and more strength than the workpiece. When they come in contact with each other, the tool will wear less, but it will wear out the workpiece more. That means more material removal rate will happen to the workpiece, lesser wear or material removal rate will occur to the tool. That is what is happening. So when very high speed speed running systems come in contact with each other, they collide with each other, then forces are generated. And if you have forced those materials, high speed moving materials to each other, you have pressed those materials to each other, then one will always try to wear out the other one. But who will wear out more? The lesser, harder material or material having lesser strength will wear out more. the material having more hardness, more strength will wear out less. तो जो less wear होगा वो tool है, जो ज़्यादा wear हो रहा है वो workpiece है. So this is a simple machining process. Okay. Just a second.
Yes, sir.
Just a second. Hello. So, okay. So continuing with basic elements of mechatronic system. So simple CNC machine comprises of a workpiece and a tool. In a turning process, the tool is fixed and the workpiece is rotating at very high speed. In a milling process, the workpiece is stationary and the tool is moving at very high speed. Okay, so this is what is happening. So if we consider the machine tool to be a mechanical system in this case, and the tool is rotating now. Suppose you are considering a milling machine. So tool is rotating at very high speed. So whatever is the RPM of the tool at a given instance of time is sensed by the digital or analog sensor. Okay, a digital or an analog sensor. So we have number of sensors available with us, which works on number of different technologies you must have studied. It can be electromagnetic, it can be working on magnetic fields, electrical signals, optical signals. Okay, so accordingly they will give you some signal when the movement of the spindle or the movement of the bed in the CNC machine is measured through these sensors. I won't be going in details of type of sensors because that has been covered in the mechatronics part, I hope. Okay, so for linear movement or for rotational movement, you have number of sensors which can sense the RPM, the linear distance covered. Okay, so these sensors in a CNC machine actually do what? They sense the location of the bed, they sense the location of the spindle, speed of the spindle, okay, with which speed it is moving. That means it is attached to the motor which is actually doing the work. So motor is resulting in the movement of the spindle also and movement of the bed. So whatever is the movement is sensed by the sensors, and those sensors will give the signal to a microprocessor. So microprocessor will always compute the data in the digital form. So it requires the input also in a digital form. So suppose your data is in analog form. Okay, so you have, if 10 millimeter distance has been moved, so you need to convert that 10 millimeter to 0101 form, digital form. That is done, and that data is fed to the microprocessor. So for converting from analog to digital form, there is an analog to digital converter attached in between. So microprocessor will now read the data, that this is the actual data which is coming from the mechanical system to me, and this is the user input data. So user input data उसके पास कहाँ से आया? जो आपने program लिखा था उसमें, from that it has read the user input data, and now it is also comparing it with the actual data which is coming from the mechanical system. And if when doing that comparison, if it sees that actually 10 millimeter of the movement was defined by the user and it has actually moved 10 millimeter, then I will signal the actuator. That means I will signal the motor to stop. Otherwise, if it has only run a 5 millimeter distance, but the user has defined a 10 millimeter distance, then I need to move 5 millimeter more. That means I will keep on giving the pulse signals to the actuator or to the servo motors to run more of a 5 millimeter distance. So this is a very fast cycle which is going on. You are getting the data in microseconds each time. तो 1 मिलीमीटर मूव करने से भी पहले 10 बार डाटा आ जाता है माइक्रो प्रोसेसर के बाद पास, है ना? तो इट कीप्स ऑन एनालाइजिंग इट that the system is still moving and moving and moving. Once it has reached its position which the user has defined, now I will signal the actuator to cut off the supply to actuator. That means electrical supply to the actuator will be cut off and no more movement of the motor will happen. Okay, this is how the mechanical system would be controlled. Mechanical system is being analyzed by sensors for its movement, and that microprocessor now senses that data in the digital form and compares it with the user input data and keep on giving the signal to the actuators to keep the mechanical system running or to stop at a given instance of time. Now, before giving the actuator a signal, it needs to be converted again from digital form to the analog form. Okay, analog form. So 10 millimeter distance, again it is a analog value, discrete value that will be again required by the actuator. That means motor will require the data in the analog form. So understood that from again digital form you need to convert it to the analog form. So digital to analog converter is placed over here. So mechanical system attached to a sensor giving data in analog form, which needs to be converted to digital form, then processed in the microprocessor, then data from the microprocessor coming in the digital form, then again needs to be converted to analog form, then analog and actuator is running the mechanical system. This is the general trend, but there may be digital actuators also where there will be no requirement of these converters. That means this converter will be integrated into the actuator itself. Similarly, analog sensors could be there where there is no requirement of analog to digital converter. It is integrated in the system itself. Okay, it's like that. So understood this part also, I hope.
Yes, sir.
Okay.
Yes, sir.
Now we will start it tomorrow, the mechatronic system and various systems which make a mechatronic system. So we will firstly start with the simple system, and this simple system will be further divided into three parts: modeling system, measurement system, and connected systems. So what are those? We will just see. So a simple system, as we are discussing, it is a simple conversion of one input value to some other output value. So from one form of input, if you are converting it to the other form of output, which is useful to you, that would be called a simple system, like a thermometer. What the thermometer is doing, you are having the temperature of human body, of the room, any place. But a temperature is there. We know there is an entity called temperature. But that temperature cannot be read by humans directly or sensed by humans directly. You can feel that it is cold, it is hot. But what is the exact value that you cannot know? So what is the useful thing for the humans? That you record it on a number scale. Okay, standard scale is there, temperature scale, which tells you the degree of hotness or coldness. So you need to convert that temperature to a useful output on a scaled number. That is, so you will be requiring a simple system in between, which will be converting it from one input to another output form. So thermometer is an example of a simple system. So such type of systems which we will be discussing in the next lecture. So till now, any doubt?
No, sir. No such doubts.
No doubt?
Yes, sir. No such doubts still here.
Okay, then thank you very much. We will end the lecture now. And for
Thank you,
your
sir.
for you who ever has missed the previous lectures, I have uploaded the lectures also on the Google Classroom. You can just go through them. Okay. And the PPT also for the first chapter, I have uploaded it on the classroom. Okay.
Okay, sir.
Thank you very much. Thank you.
Sir, I wanted to ask, have you discussed the topics with the Gurdial sir that have already been done in his classes?
The mechatronics part?
Yes, sir.
No, I haven't discussed it. So these parts have been already been done in the class.
Yes, sir. Some of the parts have been already done.
No problem. This is just a little glimpse of the things. The main
Yes,
part,
sir.
as I have told you, like 60% of the part would be based on hydraulics and pneumatics. And
Yes, sir.
around 20% of the digital logics and the PLCs. This is only covering the around 10% of part. And especially the
Okay, sir.
mechatronics part, it is just 4 to 5%. Okay.
Okay, sir.
Previously, this used to be a single subject, the mechatronics and industrial automation. They used to be combined with each other, but the syllabus was too much. So it has been split into parts because your sensors and actuators was covered in this subject only, but now it is a part of the mechatronics subject. Okay. These subject,
Yes, sir.
both these subjects go hand on hand. So that is why we need to repeat these 2-3 topics again.
Okay, sir.
Okay. Okay. Thank you.
Thank you, sir.